So going through the homework, I'm gonna do number 5 first. And this was just solving for sample size. I don't think I need to write it all the way out. You end up having, you start with your equation where your pieces are 5 is your margin of error. Your confidence level is 95%, which gives you a Z of 1.96. And it gives you a sigma of 42. So, what? Oh, it's standard deviation. Yeah. It's kind of, I'm not even looking at that right now. It's from 4.
It's from 4, it's sigma.
It's from 4, so it is sigma.
Should it be sigma or should it be S?
It should be sigma. And then, so when you rearrange your equation, you end up at the end with 1.96 times 42 divided by 5, and that whole thing squared, which when you type it in that way gives you like 271.0 something. So your answer should be, your n has to be at least what? 272. Do I need to draw that out or write that out or do that, or is that enough? Say that again. Yeah. Just writing, because when you write n is greater than, like, some people are going to write it and get the credit, but they're going to say we need at least this much. But if you do n greater than or equal to, then that's enough of your wording. And then number 2 from the other worksheet. I might just talk through pieces here or talk through it generally instead of writing it all the way out, and I can write out the do section. What is, so our state should say we what? Want to estimate, which symbol are we estimating?
U.
U, which is the true mean, what? Amount of, and that one's easy because part A gives you the wording with the mean, whatever, and so use that exact. So I would say, we want to estimate mu, the true mean amount of NOx emitted by light duty engines of this type with what? With 95% confidence. So then plan, your method should be a one sample what? T. Don't forget that when you do that part, what else do I need with that? And where does my arrow point to? So don't forget that part. My first condition is what? Random. Does this one say random? So stated random sample as opposed to random assignment. The next condition is what? Normal, what will I do there? We do central limit theorem because our n is greater than or equal to 30. Now, I've told you I'll take different things there. I need to see the word central limit theorem, and I need the fact that 40 is greater than or equal to 30. Whether you write this or you write this, but I need to specifically see that your n is going here. You're checking to make sure it's greater than or equal to 30, and it's called central limit theorem.
No, I just had a question. So would it be, is it random selection or?
Yes, random selection. Sorry, I didn't say that. Yes, it says stated random sampling, parentheses, random selection. Do what? I need to see that it is selection versus assignment. So I need to see the word selection. So once I get to central limit theorem, I write that down, then I have to end with what? So we can use normal approximation. Independent 10% condition, y'all are pretty good with this. Capital N is greater than equal to 10. N, your sample size is 40. So there are at least 400 what? Light duty engines of this type. So you would specifically need to say, that's pretty much as word specific as I would need it. We need light duty engines of this type. So confident, the do section itself, what do you get as your T critical value? 2.042.
So why are you using T instead of G?
Because the standard deviation that it gives you is specifically for the sample and not for a population. And that's your whole decision process. So the question was, why do we use T? It's because the sample, the way I think through this, and this is the part where people have issues with, so I want to make sure to make a point about it. I think through the fact of, what is my sample? It's the 40. So that standard deviation, is it talking about the 40 or is it talking about all of them? And so if it's talking about that specific sample, that's your S, which is your decision to do T. So like that's my thought process of how I would go through that. So our X bar is 1.2675. Our T is 2.042. Our S is 0.3332. And our N is 40. So plugged in, it would be, and I'm just skipping 2 here so we don't have to go over the whole thing. Plus minus 2.042 times 0.3332 over square root 40. And you end up getting, what's your symbol in between? U, because that's what we're estimating. And you get like 1.1617 and 1.3751. And y'all might do better than me. What are our units for this, grams? Grams per mile. So your conclude would start with what? We're 95% confident, and it'll be that U, the true mean amount of nitrous oxide emitted by light duty engines of this type falls between 1.1617 grams per mile and 1.3751 grams per mile. Questions on any of that problem? I'm just splitting my videos